So, good evening to all of you. So, everybody must be enjoying. So, let us start with, I said space technology, the next part, and you know that space technology is the most important aspect covers for the India. And yesterday we have covered the so many aspects of I said low Earth orbit. Now we are going to go for the not mu I will come after that. It is geo. So we will have to start with, I said that geo, or better to say geosynchronous Earth orbit, geosynchronous Earth orbit. Clear? And as you have seen that if here we have an Earth and this is your equator, this is your equator, and you know that the Earth rotates from west to east. Earth rotates from west to east. It rotates from west to east. So it rotates from west to east, and at the same time if our satellite will also rotate from west to east, our satellite will also revolve around west to east, and our Earth takes around 24 hours for one rotation. So rotational period of Earth is 24 hours, or better to say 23 hours 56 minutes 4 seconds. 23 hours 56 minutes 4 seconds. Rotational period of Earth is 23 hours 56 minutes. So one rotation covered by Earth like this, and in the same direction our satellite is also moving and revolving around the Earth above equator. Revolving satellite. Now I am talking about satellite. Satellite revolving around Earth parallel to equator, revolving around Earth parallel to equator at 35,786 kilometer with revolution period 24 hours, or better to say 23 hours 56 minutes 4 seconds. So one part it is about the satellite, another part it is about the Earth. So the rotation period that we can be able to see like that we can be able to see like here that the satellite Earth rotational speed and the revolution of satellite. Rotational period of Earth on its axis is equal to the revolution period of satellite at a height of 36,000 kilometer, or better to say 35,786 kilometer. So we can be able to say that from this position of the Earth, from the particular position of the Earth, if I will say that this satellite will always look stationary, this satellite will always look from a particular position, you pick this position anywhere, so that position, that satellite will be always there. So satellite is, I said that in the upper atmosphere at 36,000 kilometer is completely fixed, is completely, I said that you can be able to see here that suppose these are the three satellites I am showing, and these satellites are completely, I said, and above the equator, and it is completely, I said that as the Earth rotates, similarly it is also revolving, and with respect to particular position, you can be able to see that with respect to particular position it is always fixed. So we can say that it is in a geostationary with respect to a particular position of the Earth, with respect to the position of the Earth, that you can be able to see it is always fixed, it is always fixed, and it is above equator, and you know that it is above equator, getting my point, and it is above equator. So what is the geo, I said that it is synchronized, that satellite is synchronized with the Earth position, synchronized with the Earth position, and with respect to an Earth it is looking fixed, it is never changing. If anybody is on the Earth, they will find always it is at the same position. You can see here also with respect to a particular position, with respect to a particular position on the Earth or anywhere on the Earth also. Suppose I said that anywhere you can also see. If I say that with respect to this position, or with respect to, if I say that if I am talking about with respect to this position it is always here, with respect to this position it is always here, with respect to this position it is also always here. Matlab if you are watching from here, it will always look at the same angle, it will always look at the same angle. From this position of the Earth, it will always, this satellite will be never changed in any time. From here it is also, it is always looking, means any point on the Earth, if a satellite is visible, listen me carefully, suppose you can be here, take this bottle, it is coming in the picture, Vikram, this is visible, no? Okay. Suppose I said that, suppose this is the bottle here, it's like in a satellite, and here Earth, and it is above equator. So with respect to any position, if I say that it is looking stationary, suppose I am watching from here, it is always at the same position. I am watching from here, it is always at the same position. I am watching from here, from where you can see from the Earth, it is always looking at the same position. Suppose I am here, perhaps it is here, I am saying, here it is always looking at the same position, it is not changing this angle. Suppose I said that suppose I am in India, from the India it is looking at this position, Suppose I am in the Sri Lanka, the Sri Lankan people are watching always that it is the same position. Suppose I am in Africa and I am watching from here, so it will be always looking at this angle. Okay, from suppose I am in Indonesia. Suppose I am in Indonesia, so from here it is looking like this angle. So from any position on the earth, if I am in Australia and I am able to see this satellite from the Australia, so with respect to Australia, at a particular angle will be there, and that antenna means if I am in India, then I will say that this angle, my antenna will be this angle, always it will be, and we will be able to see this angle. Oh, this satellite is there. If Australian antenna will be always fixed toward this, so I can say that a particular satellite is always looking with respect to any position stationary. So with respect to geographical region of the earth, this satellite is stationary and completely synchronized. This is a geosynchronized, it is synchronized with the earth, and we can be able to see that, and it is looking stationary, so we can say that it is in a geostationary satellite. Geostationary satellite. Thank you. I said that what is geosynchronous? I said that satellites should synchronized with the earth, and in which condition it will synchronize. The first important point is I said it should first important point is that it should above 36,000 kilometer above the earth's surface, means around 35,786, but most important, rotational period of earth should be equal to the revolutionary period of the satellite, and in the equatorial plane. In which plane? Equatorial plane. Then what will happen? This satellite will always, according to the earth rotation, it is also rotating, and it is also revolving, and it is looking like at the fixed position from there, from anywhere in India you will see, from any position of, I said that Africa, backward can't see this satellite, yes or not, because one geostationary 36,000 kilometer height satellite covers 1/3 of the earth. So any position of 1/3 of the earth will find it is fixed. You can be able to see here, that you can be able to see here that 1/3 position of this satellite, this is the 1/3 position of this, 1/3 position is covered by particular satellite, and it is looking stationary. So up to which the 1/3 area, from any 1/3 area of the geographical region where the satellite is covering their signal, I said that from there it will be always visible. Is this clear? It is clear. So what is geostationary satellite? Yes, I will come on to all these points, yes. Not from the naked eyes, beta, not from the naked eyes you can be able to see. It is required some telescope to watch all this. It is, I am talking that therefore I said that suppose you are watching your, I said that dish antenna, if you have heard about your dish antenna, and any antenna that you have getting some information, broadcasting, TV channel, they have an always fixed. Suppose somebody will be, I said that the way we are looking from Delhi, the way somebody is looking from Jammu and Kashmir, the way somebody is looking from Myanmar, so there will be some angle to see this, but they will always see particular angle, means I said that any geographical region on the earth, it is looking at same position, yes or not? So I said that what is geostationary satellite? So first point, I said that these satellites are at a height of 35,786 kilometer. Second, such satellite has revolution period which is equal to the rotational period of earth. Third, geostationary satellite lies in equatorial plane or parallel to, and it is at height of 35,786 kilometer, parallel to equator, or it is lying in equatorial plane. You can say that it lies in equatorial plane, that you have to say. So this is the meaning that it is completely synchronized. Synchronized, you understood that, but at the same time it is from the different geographical region, it is looking stationary. From the different geographical region, the 1/3 of the area which is covering, that I am saying that it is covering, yes, tell me, it is covering what? 1/3 of the regions. Sorry, it is covering how much? 1/3 regions, and from any 1/3 regions it is looking what? Stationary. Therefore, such geosynchronous satellite is known as geostationary. Getting my point? Whenever, again I am telling you, the last time I said that when a satellite has a revolution period equal to the rotation period of the earth, then it will synchronize with the earth. Such satellites are known as geosynchronous satellite. But when this satellite is looking stationary from any point on the earth's surface in the visible range, it is known as geostationary satellite. So geostationary satellite is a type of geosynchronous. Geostationary satellite is a type of geosynchronous. So the point that I am going to, I said that, understand here, I said the geosynchronous earth orbit, the first point, what is the height? Yes, tell me. Above the earth's surface, 35,786 kilometer. And one thing I said that, yes, revolution period of satellite is equal to rotational period of earth. It is clear, and that is, I said that 23 hour 56 minute 4 second. Then such satellites are known as what? Geosynchronous. In this case, satellite will be synchronized with earth. Clear? Geosynchronous satellite. Again, what is the height? This revolution period of this satellite is equal to the rotational period of the earth. Then it is looking, I said that somewhere that synchronizing with the earth, that is 23 hour 56 minute 4 second. In this satellite will be synchronized with the earth. Therefore this is known as geosynchronous earth orbit. The same thing if I say that height, revolution and all. So same thing if I say that geosynchronous earth orbit, also called as geostationary earth orbit. In the case first I said that height is 35,786 kilometer. Second, it is, I said that rotational period of earth is equal to revolution period of satellite. This is the second, I said that, and it is parallel to satellite is parallel to equator. This condition, parallel to equator or lies in equatorial plane. So when it is lies in equatorial plane, then such geosynchronous earth orbit means it is synchronized with the earth. In such condition in such condition from the visible one third area of the earth, in such condition from the visible 1/3 area of the earth satellite will be looking stationary. Clear? Satellite will be looking what? Stationary. Satellite will be looking stationary. Satellite will be looking, I said, stationary. Getting my point? So this is the thing that I have shown you through the different animation that it is fixed, means a particular angle. Suppose I said that suppose you are on your roof of your building, and suppose you are on the roof of your building and you are like this, and somebody, and there is a series of other building, from the another building, that portion will look at you, another building portion will look at you, from the another building portion will look at you, another building portion will look at you. From the each respective building you are stationary, yes or not? From the first building you are here, it is, you are not changing your position. From the second building with respect to that you are also here. From the third building you are also here. If I say like this, the same concept is here, like suppose you are here and earth is like this, this is an equatorial, and from here that it is always fixed. The same here, from here you are always fixed. You means from there you can always see here the same position. This building portion will always see, and any point on the earth it will always in the same direction. This way it is same direction, this way it is same direction, it is the same direction. So A, B, C, D, E. So I said that from the position of A you are always at the same position, you are not changing, you are looking at the same angle. From the position of B you are always looking at the same angle. From the position of C you are always looking, you are not, your position is not changing, you are stationary with respect to this different position. Getting my point? Perhaps you understood. So I said that better they revolve around the earth, but it is, does not look that it is revolving, because it has to revolve. And as I have said that this picture is, here you can see this picture, this white color if you are watching, and if I make it to move, so it is with respect to the this much of the large area, this position is what I said, that if it will keep on moving here, it will also keep on moving here in the same way. So from here you are looking the same, from here you are looking the same, from here you are looking the same, from here it is always you are at the same angle of, and it is looking. So the what the figure I have drawn here, the means you are looking at the same position from the 1/3 visible area. You are not changing. So 1/3 reason, for 1/3 reason that satellite is not changing up to which this signal is reaching. So I said if I talk about here, you can see like here you can see like this 1/3, there are the 3 satellites which are covering this way. So that reason is completely, I said, that fixed. You can see that, you just feel it, that position is, I said, that not changing, this position is not changing. So I said that with respect to any position on the earth in the visible region, that satellite is fixed. Got it? But it will go to the different angle. Suppose here it is there, and this region here the signal goes like this, here the signal goes like this, here the signal goes like this, here the signal, and people from here will see this one as a this angle, from here this angle, from here this angle, from here this angle, but from there it is always in the same position. These people will always see like this. Somebody is looking at you west, always west, always west. Somebody is looking that it is you are in the north, north, with some angle. Somebody said that you are in the east, east, and somebody says no, you are in the south, south at the same angle. It is the position from where, because satellite is lies above equator. So if I am seeing from the northern hemisphere, then it is, I said that if it is lies over there, then I can say that okay, it is looking the little south with some angle. So wahan, with respect to that position, it is always similar. Do not try to become a complete scientist like this. Perhaps it is clear to you. Yes, it is always the same picture. It will never change any picture for that reason. If a satellite is above equator and it is nearby India, then it will be throughout their life, throughout the operational life of this satellite, India will be at the same angle, or Indonesia will be at the same angle, and then African country, Madagascar country, if you know, it will be at the same angle. Any country, those where it is visible. That's what I told you. Therefore, different angle animation has been shown you so that you can be able to understand it. I said perhaps it is clear to you that it is known as what? Geostationary satellite. If it is clear, so that I can move ahead. Beta, why it is high? I have told you like that. If it is Earth and then satellites are moving, if it is near to the Earth, it is moving faster. Yes, I have given you one equation, velocity equals to under root gm upon r. If the radius, if the distance from the Earth is, what I said, that radius from the Earth is increasing, velocity will decrease. Here it is the fastest and little away, little slow, little slow, little slow. Yes or not? And if the speed, here it is V1, V2, V3, V4, that the 35,786 kilometer it has been 786 kilometer, it has been found that it is taking time of revolution, it is taking time of revolution what? Around 24 hours. और आप जानते होंगे, you must be knowing, near to the earth, if you will be near to the earth, it will be what I said, that revolution period is 90 to 120 minutes, 90 to 120 minutes, moving faster, and in the small, I said, the circumference, and you are moving away, speed is decreasing and the circumference is also increasing. So you, and exact at 35,786 kilometers, satellite to maintain in that orbit move with certain speed, and it takes 24 hours, means 23 hours 56 minutes 4 seconds to revolve once. And because of the revolution, therefore this height is required. So if I talk about, I said that if I talk about, this is your, I said in the low earth orbit, it is taking 90 to 120 minutes, because low earth orbit height is from the 300 to 400 to 2000, and in the medium earth orbit, that is at the 20, और आपको मैं बता दूं 20,200 kilometer. At 20,200 kilometer, it will be 12 hours revolution period. 20,200 kilometer, because here the speed is comparatively, I said that the speed is little lower than the low earth orbit, and it is also circumference, and now at 35,786 kilometer, the speed further decrease and the circumference increase, it is taking 24 hours. So you must remember that at 20,200 kilometer, revolution period is 12 hours, and at 35,786 kilometer, it is 24 hours. And 24 hours, we will always talk about 24 hours, but the exact number is 23 hours 56 minutes 4 seconds. This is clear to all of you? Better do not ask this question, get collision if there is a more than one satellite. I am talking about, I say that I am talking about, this is that you should, if I will ask beta, you are now new to all this, and go and ask those who have prepared 3-4 years. I am giving you challenge beta. Go and ask them what is the geostationary. Today whatever you will study, whatever you have studied yesterday, and go and ask the student, those who are preparing since 2-3 years and they are very well knowledge, and if you will start sit with them, understand space technology, read that, you will find that your study of 2-3-4 days is far better, far more than their studies. 1% student I can't say, but I said the rest of the students in the same position. So please, you are asking the collision. If you have understood, this is clear. I said that yes sir, I said that 24 hours, again I said, this is your, I said that Earth, this is your Earth, this is your Earth, it is low Earth orbit, it is medium Earth orbit, it is geo. I said if it is, perhaps you remember the first day class, I said when I am talking about V equals to Gm upon R, again means radius keep on increasing the speed. Here the V1 speed, here the V2 speed, here the V3 speed, and you know that V1 will be greater than V2, V2 will be greater than V3. So who has highest speed? The satellite which is moving at the low Earth orbit, and comparatively the satellite moving in the medium Earth orbit, it will be, I said that taking, I said somewhere speed will be lesser than the low Earth orbit, and the satellite moving in the, I said at geo, it is moving with the lesser speed, because they have to, what I said, that particular speed according to that, with respect to increasing distance away from that, it should have this speed, otherwise it will not sustain in that orbit. So ये तो आप जान गए कि you come to know that V3 is lowest than the V2 and V1. So it has lowest, and at the same time you can see that it is a large circumference, it is 35,786. So large circumference it takes, and for covering its time period is, revolution time period is 24 hours. And if it is, I said that at the height of 22,200 kilometer, the time period will be, I said that speed will be little faster, but the radius is also 20,000, so it is taking time period is 12 hours in the medium Earth orbit. But medium Earth orbit start from 8,000, yes or not? 8,000 to 20,000, perhaps remember. Therefore time period is from 5 hours to 12 hours, and geo is time period is 24 hours, okay, and then it is moving fastest, and you can be able to see that Leo will have a time period that is 90 minutes to 120 minutes, and that you can say that around 1.5 hour to around, I am always saying around 1.5 hour to 2 hours, and you can see that low Earth orbit how much faster they are. You can see like satellite moving in the low Earth orbit, this is the satellite moving in the low Earth orbit, it is, I said, very fast. In one revolution it takes 90 to 120 minutes at different height. So but if you will go into the medium Earth orbit, it will take at 20,000, at 8,000 kilometer, it will take 5 hours, and if you will go away from 20,000 kilometer, it will take 12 hours, and if I will go to the 35,786 kilometer, it is taking what, 24 hours. So, importance of a satellite is very much when it is up to the 24 hour. Any satellite, if it is somewhere, it has to work something for the human being on this earth, then it can be fruitful till the 24 hour. Isliye we are not putting important satellite which are observing earth, it is working for the earth, it is not beyond 24 hour, beyond this I said that geo. So, you can be able to see I have given you some point, here it is. What is the time period of LEO low earth orbit is 90 to 120 minutes, medium earth orbit 5 hours to 12 hours, and 12 hour where it is 20,200 kilometer, and 24 hours it is at 3,578 kilometer. Therefore, and when it is moving at the same revolution period of the earth, same revolution period of the rotation period of the earth, then it will always look synchronized with earth. So, therefore, geosynchronous earth orbit exists at only one point. If somebody asks why geosynchronous earth orbit is known as geosynchronous, because at this height, the rotational period of earth is equal to the revolution period of the satellite. Therefore, it is somewhere synchronized with the earth. Therefore, that satellite, that orbit is known as geosynchronous earth orbit or geosynchronous satellite. So, this is the way you can be able to answer. Is it clear? Beta, it is the technology if will decide some satellites for 5 years, some 10 years, 15 years, 20 years, their operational lives are made according to the technology. Clear? After that they have to leave this orbit. So, we have been able to understand this one, and do not get into if I have to say something, na, better to make you to understand. If you tell me yes sir, I understood, fast move ahead, then I can be able to move ahead. Otherwise, you will chalk me here and it will take too much time, and then I can miss something. I have said that geostationary earth orbit is above equator. I did not come till now on the geosynchronous. You have stopped me up to this geostationary only. So, geosynchronous I have make you to understand, but geosynchronous I will have to tell. Now, if it is geostationary is clear to you, then I will have to come for, I said now my question is here, look at this geostationary orbit, their signal is going slant in the polar region or high latitude, it is going slant or vertical. Signal of satellites, signal from the satellites, again I said that satellite signals which are, I said that satellite signals of geostationary earth orbit is toward the high latitude, or better to say to the polar region, is going slant or vertical. Slant must be understanding. My question is this is your geostationary orbit, or this is satellite above equatorial plane, and the signal sent by this geostationary earth orbit satellite going to the polar region or high latitude, is slant or vertical, I am asking, it is slant or vertical. It is slant or vertical. Polar region and high latitude region, that is 50 degrees, 60 degrees, 70 degree, 80 degree. If it is a 50, 60, 70, 80 degree like this, 90. So, here the signals will go slant or vertical. Yes, everyone. Beta, that thing you must have studied in the, I said that in your geography classes also, you must have studied in the geography class. If you have, if your geography class has been taken place, then you must have studied. Let me tell you like this. If this is our earth and it is equator, and a satellite is at 35,786 kilometer, and then signal towards the pole will go towards the, these are the 50 degree, 60 degree, 80 degree, here it is 50 degree, 60 degree, 80 degree, 90 degree. So, in the high latitude region and in the polar region, these signals are coming slant or vertical. The signals are coming slant or vertical. Again, I have made a very clear picture. Those who have made some mistake, please make it clear that what it is. Will it be slant or vertical, everyone beta? Because after that you can come to know about. So, and these are the satellites, for the telecommunication, you know that broadcasting, I have discussed earlier. These are the satellites which are working for geo satellites, you know that. Suppose, again I said that this is our earth and here the satellites, and this is 50 degree, 70 degree, 80 degree, 90 degree. These are the high latitude region and these are the polar region. Okay, and the signal has to go like this. And you know that Russia, North America, Canada, these are in the high latitude, very colder regions. Yes. And then again I am making another picture, that this is the equator and here we have a geostationary satellite, and if there is a mountains, if there is any features, and I said that buildings in the city, these are the plateau, mountains, buildings. If I said that if the signal is going from there slant, can we say that these mountains, plateaus, buildings will obstruct the movement of signal? Next, my question is that in the high latitude, बेटा मेहनत क्यों करें, हमें आसानी से चाहिए. I need the signal in very easy manner. Instead of doing hard work in the mountains, we can put into the buildings. But again, mountains is a higher. You know that perhaps you understand that this is this city is over there and surrounded by all side mountains. The mountains, my question is, mountains can obstruct the signal of geostationary earth satellite? Mountains can obstruct the signals from geostationary earth satellite? Mountains can obstruct mountains, plateaus and all. If it is going like this, just utilize your mind beta, all of you. It is a very important question I am asking. And you have to, this is the equator and here we have a satellite at 35 geostationary earth satellite, and here is the mountains, and here it is your I can make another picture like this. Suppose this is, I said that the satellite is sending the signal, and your mountain is over here, or your city is here. क्या ये this slant signal can be range of mountain ranges? These are the mountain ranges. Can it obstruct? अभी भी मैंने पिक्चर बहुत क्लियर बना दिया. I have made the picture very much clear so that you can answer it. The reason behind in the high latitude and the polar region, where the Russia is there, Finland, England, Europe, all these countries are in the high latitude, and there are also mountains are there. You know that mountains, people lives in the plain area and not into the mountain area, and mountains पे structure बनाना, it is very hard to make a structure onto the mountains. So मोuntains generally obstruct the signals, and therefore we can say that geostationary satellite of geostationary earth orbit is not good for high latitude and polar region countries. High latitude and polar region countries. Getting my point? And this is, I said that, so the geostationary earth orbit satellite is not good for high latitude and polar region, but you can be able to see like it is good for, I said that low latitude country. It is coming without any kind of obstruction. It is coming vertical and little away from the vertical, little. So it is good for low latitude countries and tropical countries. It is good for tropical and subtropical countries. ऐसी understanding you can't be able to find in the books. I said that it is good for, so I can say that it is good for which, I said that good for tropical and subtropical countries, means low latitude. Means I say that they are giving proper signal in the low latitude and very good signal in the low latitude. So can we say that Russia, European country, Canada, USA, China, these are countries which are in the high and little mid latitude and polar region where the signals are not going proper. So they can't, these countries do not use geostationary earth orbit satellite for telecommunication. So I said that these are the mid latitude countries. बेटा शैडो सन रेज का होता है, वेव्स का क्या शैडो होता है? That is signals are in the form of frequency. It is clear? Suppose कभी कभी क्या करते हो, आपने देखा होगा कि you are there is a Wi-Fi in one room and another side there is another room, then the proper Wi-Fi will not come. Yes or not? लेकिन you know that there is some obstruction will be there. Suppose you are in the first story, your room is in the first story and second story, just above second story, Wi-Fi signal will not go into the second story, and the same way other, because there are someone who is obstructing the signal. When the signal will be obstructed, then it will not be able to go proper. Getting my point? This is clear. And then it is not about the sun rays. Sun rays have a lights. I am talking about the different things. I am talking about here signal. Next important point I say, if I say that the country like low latitude, tropical and subtropical countries. शायद आप लोग all of you know that what is tropical and subtropical. Then it is in the low latitude like India, Pakistan. They are, I said that geosynchronous Earth orbit satellite is good for telecommunication. It is clear, it is good for telecommunication. So India ke liye which one is geostationary Earth orbit satellite is good, which is above the equator, but in the Russia, Canada, USA, European countries and all these Chinese countries, those who are jahan pe thand bhi hai, and all this, they are the rays are coming, means I am not talking about the sun rays are coming slant, I am talking about I said that suppose your phone signals are there, and when your phone signals or any telecommunication is taking place, it will be obstructed by this. They have to move. There is an, I said that therefore if it is obstructed, then you will not be able to, you will get lots of problem in between in the signal, and then you will think of removing this. I said do not use this telecommunication. Somewhere you will get the problem in your telephone, you will get problem in your TV channels that they are not proper working. Clear? Another point I said, then how do they, so which satellite, then how, which satellite can do the function or work for better signal in high latitude and polar region. So which satellite? Question is which satellite? So if I say that which satellite, this question is arising, and you can be able to go and see the several videos, questions and topics in your different books. You will find that the people are not able to clarify that how do there is a difference between GO and what is the difference between geosynchronous, geostationary Earth orbit. They will talk about this is moving this way, this is moving, and do not talking about the exact picture into the mind of the students so that they can understand. So it is very confusing that it is given here and there. So let us see geostationary, you understand that it is working for low latitude, not working for better high latitude, and I said that polar region. Now if I say that a satellite, it is, I said geosynchronous. Listen me carefully. I have earlier discussed with you geosynchronous in the initial of the class. When I said that height is 35,786 kilometer. What I said that height is synchronous, and the revolution period of the satellite is equal to the rotational period of the Earth, and this in this satellite will be synchronized with the Earth. That means I said it is a geosynchronous, but when I have said that it is above equatorial plane, parallel to equatorial plane, that name becomes geostationary earth orbit. It is above the equatorial plane, here it is, clear. So, and it is moving parallel to the equator, it is moving parallel to the equator. But if I say that, listen me carefully and watch it carefully, and for the geosynchronous earth orbit, see this, what is the importance part of geosynchronous also? Means it has to synchronize, the satellite has to synchronize with earth. So, what is the requirement synchronization? It is 35,786 kilometer, and the rotation of earth should be equal to the revolution of satellite. But at that time there should be some angle, you know that, some angle. Suppose I have to cover the better signal in Russia, so my satellite should be here. So there will be a geosynchronous satellite, it is an inclined satellite. It is inclined with equator, it is not parallel to equator, it is again height is 35,786. मैं ये बार बार नहीं कहूँगा, I will say that 36,000, height is 36,000, and it is inclined with equator, and here it is above Russia, then it is covering this Russian region, parts of Russia. Maybe if it is Europe wants, then this satellite will be here, and then whole Western Europe is covered, but it should be with some angle. If it is with some angle, so I said that this is equator, and when the satellite moves into the parallel to equator, these are known as geosynchronous or geostationary earth orbit. But if it is with some inclination, with inclination 36,000 kilometer, and revolution period and rotation of the earth both are same, and if it is with some inclined, maybe here it is inclined. So this is your geosynchronous, Listen here, the character is, I said that 36,000 kilometer, and rotational period of earth equal to revolution period of satellite. These two conditions are followed, and it is geosynchronous if it is with the 2 degree inclined. I said that, better to say that 30 degree inclined, but 50 degree inclined. If it is, I said that 50 degree inclined like this, it is a geosynchronous. Why it is geosynchronous? Synchronized with the earth, and it is covering the region of Russia. Here it is covering the region of Canada. If here it is covering the region of China. So I said that 50 degree, it can be 40 degree inclined, it can be 30 degree inclined, geosynchronous, it can be 10 degree inclined, it can be 2 degree inclined, and it can be 0 degree inclined. All are geosynchronous. Somewhere it is synchronizing with the earth, because 36,000, that is 35,786 kilometer, and rotational period of the earth, it is synchronized with the earth. So these, it is geosynchronous, but who is above equator and parallel to equator at 0 degree inclined, means no inclined, then it is known as geostationary. So can I say that geosynchronous means synchronizing, and there are several geosynchronous, but geostationary is a part of geosynchronous at 0 degree latitude when it is parallel to equator. So if somebody asks what is geostationary earth orbit. If the question comes which of the statement correct regarding geosynchronous earth orbit. First statement it is talking about its satellite revolution period is equal to rotational period of earth. Clear? And therefore looking synchronized with earth. Second, such geosynchronous earth orbit satellite takes 12 hours for one revolution. Third statement, geosynchronous earth orbit satellite can be at any angle with respect to geosynchronous earth orbit satellite can be at any angle with respect to equator. Fourth statement, geostationary satellite is a part of geosynchronous earth orbit satellite. So these are the four statements which has been given for geosynchronous earth orbit. First statement is talking about, अच्छे से answer देना. I say that it's the first statement. This is the way that UPSC is asking. That's what I am telling you that you should be very good at. And lots of students are not able to clear this examination. I say its satellite geosynchronous earth orbit, its satellite revolution period is equal to the revolution period of the earth, therefore looking synchronized with earth. Second statement, आपको बताना है which statements are correct. We have to say that which statements are correct. Such geosynchronous earth orbit satellite takes 12 hours for one revolution. Third statement, geosynchronous earth orbit satellite can be at any angle with respect to equator. Fourth option, geostationary satellite is a part of geosynchronous earth orbit satellite. Which options are correct? Which options are correct? All of you, I will ask you, read it properly beta and go and ask this question anywhere to the students of anyone who is preparing for civil services for 2, 3, 4 years. Which of the statements are correct? %98 of the students are, I said that making in a correct option, क्योंकि ये रिवोल्यूशन पीरियड आपका इक्वल होता है, ये समझ में आ गया. I said that such geosynchronous ये 12 hours नहीं लेता है, 24 hours लेता है बेटा. Second statement is wrong. Second statement is, I said that second statement is wrong. First is correct. Third statement is talking about geosynchronous Earth satellite can be at any angle with respect to equator. I have said that it can be 60 degree, 80 degree. I said that it has to move at a particular angle, but the height should be 35,786. Revolution period should be the same. So this it is the third statement is also correct because it can be at any angle. I was talking it can be at any angle. It can be at any. All these are what I said that. 50, 49, 48, 48.5 degree, it can be at any angle. And another I said that इस तरीके से देखें तो it is I can say that your geostationary Earth orbit satellite, this one is a part of geosynchronous. Clear? So the fourth statement is also correct. If you have understood, then it is you will never get any problem. You will never get any problem. You will never get any problem. So I said that there is one thing is there. If I have to cover in a particular, suppose मुझे I have to cover in a particular Canada region, USA. So I should have a geosynchronous at the height of 35,000, because this Canada region is not going to get benefit of geostationary Earth orbit. Those who are at it is in the above equator. So perhaps this point is clear to all of you. So only one line that definition must be clear. Definition is not one like that we can say. Like I said, geostationary Earth orbit or satellite which are at a height of 35,786 kilometer, and its revolution period of satellite is equal to the rotation of Earth on its axis, and I said that from any position 1/3 visible region, from the any position that satellite is always looking stationary. And these are the definition complete. फिर हमने कहा geostationary satellite is a part of geosynchronous satellite, and it is better working in the low latitude, better to say that tropical and subtropical region. Thereafter I said these are, and the high latitude and in the polar region the slant movement of signals, not rays I am talking about, signals sent by the satellite, your telephonic signals, your I said that any kind of broadcasting signals, that will not go proper. That will not go proper. Then it is I said you can be able to see like then it is moving, and the high latitude is not good for geostationary Earth orbit. But I said that geosynchronous Earth orbit, which is I said that which is at the height of 35,786 kilometer, and rotational period of Earth is equal to the revolution period of the satellite, and it is synchronized with Earth, and it is revolving around Earth at an inclined plane, at an inclination with equator at a different angle. आप different angle बोलो नहीं, but even then it is inclined with respect to equator. That is geosynchronous. So I said that there is a need of different inclination for different regions of high latitude. If I need a Russia, if a Canada, there is a different inclination needs. Yes or not? So suppose if I am talking about a Himalayan region, I said that Himalayan region, and if I am talking about the northeast, ye thoda sa, if I am talking about it is in a mountainous region also. Can you think of that India's northeast, or better to say Himalayan region is little mountainous, and the world highest mountain is which one? Tell me. Now if I am coming for telecommunication in India, and earlier I have told you how do the telecommunication and broadcasting takes place. If I say that there is an antenna, some match is taking place, or telephonic service, it is going uplink, there is a satellite, and the satellite will have a transponder, and transponder means transmitter plus receiver. So this is an uplink, and it is receiving signal, transponder, and then the transponder is sending the signal through the downlink. Okay, and this is, I said that this is the telecommunication, this is the way broadcasting which is taking place. Now my question is for the telecommunication in India. If I am talking about telecommunication in India, you know that it is your India. If I telecommunication in India, if I say that this is equator and here it is your India, and the northern section of India, northern section of India is full of, I say that northern section of India this section of India is full of world highest mountain ranges, world highest mountain ranges. Okay. So if it is highest mountain, not a small mountain, you know that so somewhere there is, I said that kya India mein telecommunication is only good signal, I am talking about better signal, best signal, I need a best signal. आपने कभी लाइफ में सुना है ओ यार आई एम नॉट गेटिंग बेटर सिग्नल इन लद्दाख, आई एम नॉट गेटिंग बेटर सिग्नल इन जम्मू एंड कश्मीर, आई एम नॉट गेटिंग बेटर इन अरुणाचल प्रदेश, सिक्किम? हैव यू हर्ड अबाउट? Have you heard about that? I said that. Have you heard about Mount K2? That is okay. Himalaya, Everest. Okay. I said that it is. If I am talking about, these are the very highest mountain range over there. क्या आपने कभी सुना है? Have you heard about earlier the people are talking about I'm not, the signal in Ladakh is not good, signal in that region is not good, it is creating very much problem. So why they are creating, why it is creating a problem? Just tell me everyone, why the people living in Himalayan region what getting some problem? Why do the people living in Himalayan region, why do the people are getting why do the people in Himalayan regions are getting some problem in the receiving signals, or phone, their phone is not working? So just tell me. Everyone I am talking about, everyone. And sometimes Airtel will come, some Vodafone will come, sometimes anybody will, BSNL, MTNL, whosoever, MTNL is not there, MTNL in the metro cities. They will say that now my signals are coming here, some what I said that large antennas are put and that it is coming like, how have you heard that earlier? Why do the people are, why do this region is not able to get the proper signal? And you know that I am talking about Himalayan, average height is very 6 kilometer, average height is 6,000 meter, and it is very small valley, and then mountain ranges are there. So it is in a high level of obstruction. So I said that In Three Idiots, Airtel was there. That's good. देखो मैं बता दूं आपको ये कैसे काम करता है. Signals and all these signals which are coming. Let me tell you once, it will be very much clear. There is one tower is there and the large, and this is the part of earth. फिर उसके बाद मुझे answer देना, give me the answer. And here the telephone goes, and it is going into the upper atmosphere and it is receiving the signal, and this is the uplink, and thereafter this signal comes to the particular Airtel tower, and thereafter from this tower this signal are sent to the people. So it is not directly, any satellite is not sending the directly signal to the consumer. It is first go to this one, and accordingly it I said that amplify, मतलब frequency थोड़ा change करके then it will send it to, it will change the signal. Perhaps you have seen the one Rajnikant film 2.0, that you have seen that they are the signals, they are increasing the signals frequencies. From the towers signals are increasing. If you have seen this film, you know that. And suppose and there is if I say that there is a mountainous regions are there, if there is a mountainous region, then the signals will not be able to go proper to the in the Himalayan region. तो Himalayan region के लिए हमने बोला नहीं, मुझे क्या भेजना होगा for Himalayan region, and there will be a sum, it is not, it is a geostationary. Then हमने बोला for Himalayan region I should have some geosynchronous satellite. Yes or not? So the Himalayan region we should have some geosynchronous. Good, all of you good due to the distraction. So perhaps what I want to say that this is the clear picture. So in whole India, we need some geostationary satellites and some geosynchronous satellite with some angle to cover the Himalayas. So we should need a satellite in both kind of satellite for the telecommunication, for the broadcasting. So my point of view is clear. Beta, in the Switzerland, they have, in the European country, they have a geosynchronous satellite. It is a very good, I said that, they are the developed country, they have devised all this. In the Switzerland, there is a geosynchronous. So geosynchronous is just lying above the what, they have a certain angle it is going. So in the Switzerland, in the Russia, in the Norway, Sweden, everywhere, there is a geosynchronous satellite. I am saying that where the signal is not able to reach, I should utilize geosynchronous. Geostationary Earth orbit in India. In India, we need geostationary Earth orbit as well as geosynchronous Earth orbit satellite. We need both for the better signal throughout India. And we have sent several such satellites into the geo, that is 35,786 kilometer. Beta, every day I am trying to explain better. I yesterday go and see the video, you will find better, sir. Every bit I am doing, I am trying to teach you very well so that you can understand better. I know that what is the position of yours, so please keep on cooperating me to what I said, that I can go little faster. I said again, in India we need, for mountainous region where the signals will not be proper, there it is, I need for where the signals are not proper, I should send some, I said what? I should send some geosynchronous geosynchronous satellite. It is clear? This is clear? Yes, there is an angle. Geostationary Earth orbit is a part of geosynchronous first, and then geostationary is just above 0 degree latitude, and others are at some angle. Geostationary not making angle, it is a 0 degree and it is here. So now this picture is clear to you, that this picture is clear, that I should have some geostationary Earth orbit above equator, and I should have, I said that I should have some geosynchronous also. I should have some geosynchronous also. I'll explain beta, थोड़ा सा अभी इसको complete कराने दो. Yes or not? So India should have geostationary Earth satellite, also geosynchronous. Now, in case of geosynchronous, everyone tell me, everyone, now I'll come on to the, I'll come on to this. If I am talking about everyone, please. Geostationary Earth orbit is a part of what is the meaning of geosynchronous? Some students still like, I think everyone is able to understand. Let me again, geosynchronous means I said that satellites should be at the height of 35,786 km and their revolution period should be equal to the rotation period of the Earth. When such situation will be there, then it will synchronize with the Earth. Yes or not? And if it is synchronized with the Earth, means it is geosynchronous Earth orbit. So it can be at 60 degree, it can be at 65 degree angle with respect to equator, it can be at 65 degree, it can be 60 degree, it can be 50 degree, it can be 40 degree, it can be 35.5 degree, it can be 32 degree, it can be 15 degree, it can be 10 degree, it can be 1 degree, it can be 0 degree also. All are synchronizing with the Earth because of they have same satellite has same revolution period with the rotational period of the Earth. It is synchronized. But when it is coming above of the what I said, that 0 degree above it is equator, then it is geostationary. So geostationary is a part of geosynchronous Earth orbit. Understood it? Now this is clear. आप लोग यदि मुझे यहीं पे फंसा के रखोगे, if you'll make me to stag over here, then I cannot move ahead faster, beta. I have to lose some points and leave some point. मुझे कुछ points मुझे lose करना पड़ेगा because I have some fixed date to complete it. But if you'll take my more time and asking the question, I have said something to ask the question at the end, but you are asking so many questions. 90 डिग्री इज पोलार बेटा, वहां पे जरूरत नहीं है पोल पे, तो हम लोग 70 डिग्री का भी भेज कर पोलार रीजन को कुछ एंगल से कवर कर सकते हैं. आई कैन कवर द पोलार रीजन आल्सो विद, आई सेड दैट दिस इज आवर अर्थ सपोज, and I have to cover the polar region, and if it is the satellite is over here, then this satellite can cover this signal in much better way. It is not necessary to go to the polar region above this geosynchronous. So it can be 65, 7. Therefore, I talk about like this. Don't try to become the master of space technology. Yes, everyone is clear. Geosynchronous, geostationary Earth orbit. Now my question is, मेरा एक बहुत important question है बेटा. इसके बाद आप, if you'll go and ask anyone in the student, teachers, they are not able to give this aspects of answer to you. My question is, perhaps here the one figure I have drawn. Just watch it. This blue color line signifies for India there is a need of geostationary and there is a need of geosynchronous for the mountainous region where the signals are not able to reach. So I have to make an angle inclined means geosynchronous satellites. Yes or not? So I am covering this. One path is like this, one path is like this. So one side of the Himalaya and another side of the Himalaya, eastern Himalaya, western Himalaya we have covered. Yes or not? We have covered eastern Himalaya, western Himalaya. Now I am asking you, and watch me very carefully. If a satellite is at an angle, then it will be some for 12 hours, for some period or 12 hours it will be at the back of the earth, back of the sunlight. If it is rotating like this, it is geosynchronous, synchronizing with the earth. It is synchronizing with the earth, but it will go back. तो इसके लिए मुझे उस रीजन को दोबारा कवर करने के लिए I need one more satellite. In the geosynchronous I need always two satellites. If one is going back, another should come at this position, because it is moving. In the case of, I said that geostationary, it is moving in the same fashion, but in case of geosynchronous, one is going back, the another has to come over there in the covering the Russia. If one has gone back like this, okay, because it is at an angle, so gone back, it is rotating. It is rotating, 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 but it is, I said that coming. If it is an angle, then it will also come into the southern hemisphere. So to cover, if one is going back, then another has to come over to cover. So I need at one angle of inclination, I need two geosynchronous, one over there, one over there, means after 12 hours, so that it can come. So India has to be covered in much better way with the 4 geosynchronous, and 3, you can see that these 3 geostationary satellite. Clear? India can be covered with the better. आपने सुना होगा India is sending again telecommunication satellite, again telecommunication satellite, again telecommunication. Why they are sending so many? Yes, sometimes one is not working, then again I send in the different orbits, some geosynchronous, some geostationary. So we can be able to say that to cover India in better way and some surrounding countries and some surrounding countries, we need 3 geostationary satellites above equator and 4 geosynchronous satellite. Here you can see these are above equator, this red color is above equator, it is what? Geostationary. And again I can make map for this, that you can easily understand. If this is our earth and it is equator, and India is here, so I need to cover better that I need 3 geostationary, and if it is Himalayan region, if I have to cover, it is a geosynchronous it is going. So here it is western Himalaya, and for eastern Himalaya here it is. So one has gone back, the another has to come. Okay. So there will be 2 here, 2 here. This way we can say that 7 means 4 geosynchronous and 3 geostationary needed to cover India for telecommunication, for anything like this. So perhaps it is clear to all of you. So next point, we understand what is geosynchronous and geostationary Earth orbit. The next point that we have to see, like which satellites, the satellite which are moving in this orbit, they are known as INSAT or GSAT. INSAT I have discussed you earlier also, GSAT, INSAT or GSAT, Indian National Satellite, yeah, Geosynchronous Satellite. So what is the full form of this? Indian National Satellite, or GSAT means Geosynchronous Satellite. So in the low Earth orbit we have, IRS, Indian Remote Sensing Satellite, जो आपने कल देखा several, and in the geosynchronous Earth orbit we have, the satellites are known as INSAT or GSAT. Now what is the significance of INSAT or GSAT satellite in geosynchronous Earth orbit? That we have to see. First, already we know that it will help in telecommunication, several times I said. Second, it will be for broadcasting. Yes, second it will be for broadcasting, and then third it is for, I said, IRNSS. अभी मैं इसको कंप्लीट नहीं करूंगा, आपको समझा देता हूं. I said that IRNSS और NAVIC, इसके लिए इंडियन, जब मैं इंडियन स्पेस प्रोग्राम करूंगा that time, and there is also 7 satellites for this, 3 in the geosynchronous Earth orbit and 3 in the geostationary Earth orbit and 4 in the geosynchronous Earth orbit. You can be able to see here, like I said that you can be able to see here, like I said, that this blue color is geostationary here, 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 and these are the two geosynchronous here, and these are the two geosynchronous here. So the 4 geosynchronous and the 3 geostationary you can be able to see here. Similarly, you can also see here above the equator there are the 3, these 3, and here we have the 2 geosynchronous at certain angle. Okay, so 4 geosynchronous total. So this is the way that we are covering IRNS, and we can be able to see that it is a navigational satellite. It is a navigational satellite. अभी हम लोग केवल इम्पोर्टेंस समझ रहे हैं, बट लेटर ऑन IRNSS will be in detail. Do not ask any question, it will be useless. Again I have to explain, then why am I explaining? Later on I will explain with better ideas, because it will be in one Indian space program. So शायद आपको ये भी, you can come to know about if it is at higher height. If it will be at higher height, it will give the better navigation, our position, our latitude, our longitude, our height. Navigation में ये होता है ना, our latitude, longitude, our height and time, and then at what time I am here. So IRNS, and you know that because it is fixed, and at that point, and it is covering completely all the signals, and IRNS is much better. Our Indian navigation satellite is not in the medium earth orbit, because 24 hours it is above India. It is 24 hours above India, and not only above India, it is covering the surrounding region of India also. So the surrounding region will also get benefit of what I said, that navigation for their car or any kind of it. Earlier I have told you. So it is also working for, I said that IRNS means, if I can say the definition of IR, and it is full form Indian Regional Navigation Satellite System. So these satellites, there are 7 satellites we have, okay, to cover this all, and it is together these 7 satellites is known as, you know, that constellation, the group of stars. So therefore this is, it is because this 7 satellite is trying to find our position, our navigation, and at what time over here. Okay, so these 3 things are, and it is a NAVIC, it is known as a NAVIC. NAV means navigation, I for Indian, C for constellation. It is this group of 7 satellites together known as navigation of Indian constellation, in navigation Indian constellation. So they together all 7 IRNS known as navigation. So India के लिए best है कि all the satellites are always over India, so always I will be able to get. But if the satellite in the lower orbit, so they keep on, I said one is going, another is coming, one is going, another is coming. So we need more satellite, and there will be an अच्छा एक बात बता दूं. So one picture you can see, like, and you can be able to, I said that you can say that, okay sir, what is this? ये एंटीना क्यों बार बार मूव कर रहा है? If in the lower orbit and middle, in the lower orbit, what will happen? I need more satellite. Suppose I said that I am giving a signal, one satellite has gone there, another satellite, then it will what happen? In the lower earth orbit, what will happen? But if I said that geostationary earth orbit and then geostationary satellite and geosynchronous, they are somewhere maintained at the same height and somewhere looking always toward that. So our antenna will be always fixed toward this, and everyone, our car and all, every navigation will be able to clarify, and then where they are with more clarity it will be there. So Indian Regional Navigation Satellite System. But if I am talking about the other, so they need more satellite, because it is a fixed, because it is its rotation is also equal to the, its revolution is also equal to the rotation period of earth. But if I will go to the other orbit, like I said that the GPS system of America, I will come on to it later on, the GPS system of America, they are, I said that medium earth orbit, I will come on to it why. मैं अभी I said because ये पिक्चर से थोड़े से आपको समझ में आ चुका होगा, और ये IRNS के 7 सैटेलाइट है. यू कैन सी दैट दिस IRNS हैज 3 satellites, 3 satellites in the geostationary earth orbit, and there are 4 satellites in geosynchronous earth orbit. And I said in the medium earth orbit is थोड़ा हम लोग let us in the geosynchronous earth orbit, here it is I said that IRNS, and which one I said that navigation of Indian constellation, because it is one important thing you can remember, it is always over India, always over India. So it will give the better navigation, that much you can remember right now. It is better than GPS. If it is coming at the lower height, there will be several satellites and antenna has to move here and there. So it is creating, and then somewhere we are not able to get, and what I said that what exact navigation. So GPS में आप कभी देखे होंगे utilize करके कि if you have utilized Uber, Ola, something like this, they are coming. So it looks like they have, I said that sometimes it has reached at your home, but it is showing somewhere else, 20, 30, 40 meter away. It is showing 20, 30, 40 meter away. Getting my point? So if it is showing 20, 30, 40 meter away, then it is somewhere not totally correct. But our IRNS, if it is your the Uber has been able to reach your house, Uber cab has been reached your house, so hardly 5 meter difference can be there, otherwise it will be reached your house. So this much of IRNS there, because it is always over India. It is always over India, that much I can say that, but more clarity when I will teach you, I said that IRNSS and the GPS at that time you can. Now the next point I said that it is helping in telecommunication, broadcasting and then navigation. Another point I can say, like I said, it is the next point, it is a tele-education. And if you have heard about VSAT education, small aperture terminal, very small aperture terminal. So in the same way, like I said that, in the same way if we are here, you are, I said that suppose I am giving a lecture in IIT Mumbai, and this lecture is very much important. Suppose I am giving lecture in, I said in IIT Mumbai, and this lecture is very much important, then what can be there? Then from the outside this IIT Mumbai, there will be one better antenna will be there, and this antenna will go with the uplink, and there will be a satellite will be there. They will, I said that, amplify the frequency, and this frequency will come toward the downlink, and it is the antenna which is situated over IIT Kanpur, IIT Kharagpur, IIT Guwahati, and the different IITs have their own also, I said that this antenna, and from there this signal will come, and then IIT, all the parts of IIT has been getting the same lecture, but the lecture is, I said that it is only in, I said in which area? It is in IIT Mumbai, but all IITs are getting the similarly. So many, I said that such satellite is also known as EduSat. So this EduSat, educational satellite, कहाँ पे रहेगा? It will be also in the geosynchronous earth orbit or geostationary earth orbit. Okay, if somebody is asking EduSat, and the several universities have sent their own small satellite along with the satellites of India. So several university, maybe IITs, maybe some South Indian, some universities have sent, here and there IMs have sent there, because they can be able to have their own lecture in the different region with the help of VSAT. And the VSAT are the two types. One, it is I said that ROT, another it is I said that SIT. So if I am talking about the teleeducation are of two types in the form of ROT and SIT. ROT means receive only terminal, means here you will see that you will see the lecture of if I am giving a lecture in Mumbai, IIT Mumbai, that this lecture will be visible at all the IITs. So they will receive my video, they will receive I said that audio, but they cannot interact with me, they cannot ask any question to me. Clear? So this is known as, so it is in a one way it is in a one way teaching only. It is in a one way teaching. So it will, they will receive video and I said that audio signal, and it will be one way teaching. But SIT is talking about that there will be also their interaction. It is a satellite interaction terminal, satellite interaction terminal. So what I said that in this one there will be an interaction also. Clear? It is I said that interaction will be also there. So this is known as a tele-education. So means Geo is helping in your, I said that telecommunication, broadcasting, it is helping in the tele-education. Can I say that if it is helping in the tele-education, similarly it will help in telemedicine? Telemedicine, in the similar way I can have what connection with the, I said that some better medical institution in the different parts of world, an Indian medical institution. Suppose in Africa a doctor is doing some kind of understanding he want or some kind of operation, so they can I said connect with the Indian doctors. If they suppose their fees is low and they are the good doctors, that they will through the telemedicine they will be able to get they can be able to interact. So this is I said that it will help in the tele-education also. Another point, if I am talking about, if it is India and there is an Arabian Sea and here it is a Bay of Bengal and it is completely Indian Ocean, okay, and there is one I said that the sheep is there, and somehow he lost and this ship is sinking. Suppose you have seen the movie of Titanic. Yes, radio, TV signal, they are the, I said that it is a kind of I said broadcasting. TV, DTH, all these are what? Direct to home, whatever you are getting different kind of Airtel or different I said that channels are coming in the present time. They are giving services direct to home. What is this? They are using the INSAT satellite at the height of 36,000 kilometer. My next point is I said that one ship is I said that sinking in the ocean, like we have seen the Titanic movie. So they used to send one thing, SOS signal. SOS. So I said that SOS signal means save our ship. SOS signal, and this signal will go to the again that satellite over there, because it is very far from Indian coast or something in the Indian Ocean and it is somewhere in the problem. Then it will send an SOS signal, it will go to this geo satellites and that will send to the nearby region, those who are nearby, maybe in a Madagascar, maybe I said that Maldives, maybe India, those everywhere signal will go, those will be the nearby, they will come to know, and at the same time nearby ship will also come to know. The satellite signal will be sent to the India, Maldives and the nearby any ship, because all are connected with the signals. Yes or not? They have this device to receive it. They have an antenna to receive the signal. So they will come to know, then directly they will reach to that ship and they will try to save. So for the safety and security, it is very much somewhere it is for the safety and security it is working. Safety and it is clear to you. So many words are being said that it is, I said that save our ship. I said वो बच गए तो सारी आत्माएं बच जाएंगी. So there will be a safety and security for other. This way we can be able to see, like I said, that it is in a geo kind of it. So the what are the application, what are the significance of geo itself? And geo, it can be a telecommunication, broadcasting, and there will be, you know, the transponder who is working a lot, IRNS and all, and the I said that tele-education, and this one safety, security, and at the same time it is working, like I said, that for the weather forecast also, weather forecast, you know, that taking the picture from there for the cyclone, monsoon and all. So it is talking about monsoon and other climatic phenomena. So this is talking about these are the functions and significance of we can be able to see geo. Perhaps this will be completely clear to you. You will not have any problem. No beta, those who will be there, वायलेशन विल बी देयर जब आप किसी और के ओशियन के जो स्पेशल इकोनॉमिक जोन के जो कोस्टल रीजन विच इज द कंटिग्यूअस जोन, इफ यू आर एंटरिंग इनटू द, आई सेड दैट in the coastal region of the any country where there is a contiguous and that the law of that country is working on it, if you are entering into without permission, then there is a problem. But if it is somewhere any ship is moving, so it will not create any problem. But हमें कुछ क्या करना है, बचाना है जो भी नियर बाई है. So यहाँ तक कानून वगैरह की बात नहीं आएगी. So we have covered with, I said that which one, and or geosynchronous, geo earth orbit 35,000, orbital period 2500, 2400, better to say 23 hour, 56 minutes 4 seconds, and several significance and ideas we can come to know about. So the next point, if I talk about it, is medium earth orbit. And medium earth orbit height, already you know that it is 8,000 to 20,000 kilometer. 8,000 to 20,000 kilometer, and I said that its orbital period or time period of revolution, orbital period is 5 hours to 12 hours. अभी मैंने बताया था 5 hours to 12 hours. 5 hours to 12 hours. And now if I am talking about medium earth orbit, what I said that medium earth orbit, India doesn't have any, India's no satellite. कोई भी सैटेलाइट यहाँ इंडिया का नहीं है. अब मुझे बताओ, if we come to know about all this, I can get the better navigation by the IRNSS. Why should I put my satellite and and this IRNS at the geo level? They are always overhead India. They are looking India, always covering the India. So why should I need any satellite who is moving around, but it is not completely so overhead? So यहाँ पर if I am talking about, listen me, in the medium earth orbit, this is the earth. And I have told you, if it is at the height of 8,000, then in I said that 8,000 it can complete in 5 hours, again in the 10 hours, again in the 15 hours, again in the 20 hours, and then 25 hours, it can complete 5 revolutions. It is in the 8,000, it is covering like this, yes or not? So I need I said that in the MEO, medium earth orbit, there will be a camera can be better, there can be, and I said that transponder can be better, लगाया जा सकता, but not, it is in the, I have talked about this thing earlier, transponder, because it is not at the like Geo, it is not like a Leo, but there could be at the medium height where it can utilize the camera also of good quality, not better quality, and also there is a transponder. So like if I say that my question is, these are the character of medium earth orbit, if I say that medium earth orbit, height is 8,000 to 20,000 kilometer, orbital period 5 hours to 12 hours, and another point is camera and transponder can be utilized both in the equal. In the low earth orbit better camera, but transponder little bit they can utilize. In the high earth, in geo earth orbit, transponder better, but they can also utilize, I said that, cameras, but they're not of that much better way. जैसे मैंने टेम्परेट ग्रासलैंड के लिए बताया था कि दैट इज आई सेड दैट व्हाट इज द मीनिंग ऑफ टेम्परेट ग्रासलैंड मींस ग्रासलैंड विल बी देयर बट along with there will be some trees also, but in the medium earth orbit camera and it can be also. Now tell me, if I am talking about where is USA, where is Canada, where is Europe, where is Russia, where is China, where is Japan, all these countries, if you see, like these countries are in the somewhere mid latitude and little high latitude countries, mid latitude and high latitude, yes, or near to the high latitude you can say, also some mid latitude. So in these countries, kya in these countries, listen me carefully, geostationary earth orbit satellite will not work properly. And second one, they want also one thing, that the camera can also work better way. They are in the high latitude. They are in the, what I said that. So geosynchronous and geo earth orbit I had talked about little bit good in the condition what I have discussed earlier. But if those countries, those who are in the mid latitude or high latitude country, and they need a navigation needs, and navigation if it is they need, and in this region, and if I talk about, if it is in a GPS system of USA, पहले मैं बता दूं, in the medium earth orbit USA is utilizing their GPS system. Europe is using, I said that Galileo, Europe is using Galileo, and another I said that Russia has also series of satellites for navigation, it is GLONASS, Global Navigational Satellite System. And I said that China, earlier I have said that China is using BDS system, BDAO system, all are somewhere mid latitude and little high latitude countries, okay. And they need to cover the, I said that better signal in their country. So better signal if I am talking about, and pictures also I am talking about, yes or not? You know that better signal and better picture, मतलब ज़्यादा बेस्ट नहीं होने चाहिए, good signal and good picture. So good signal and good picture can be possible, and these are the not small area. USA is a large area, Europe is a large area, China is a large area. So they say that if I am sending my satellite, perhaps already you know that if you know that medium earth orbit is, I said that, which is able to cover good amount of area but not very large area, good amount of area, it can cover the whole North America like this, not 1/3, but it is able to cover good area. And then signal will be also, I said that in this medium earth orbit, good signal, and I said that good I said that area, good signal they are cover, and good picture also, and area is not very low, area is not very high, area is also good comparatively. So what it has been found, the good signal, good pictures. So they found it will be better to, I said that it will be better to they are, I said that they are not these countries are not near to the equator, and this is the one problem they are facing, that so they said that their satellites, I said that for their country better signals should be there. So they said that okay, and you know that there is a need of one satellite for I said that latitude, yes or not, one satellite for, ये मैंने पहले भी डिस्कस किया, I discussed earlier, longitude, yes, and one satellite for height, and one satellite for accuracy with the time clock, time clock. So there is a need of particular portion of 4 satellite, and at the same time, suppose I have to cover this area, suppose this is the European country in this region. So here it is at a height of, I said that 20,200 kilometer, 20,200 kilometer, timing is 12 hours. So what happened, the satellites keeps on moving, and 12 hours it covers one circulation, and another 12 hours another, then 24 hours 2 times it covers the revolution. And they have put in a several, because it is covering a small area, so they have put what I said that 4 satellites for covering this region, and that it is at the same time their need is to cover this one. And you can be able to say that when the 2 satellites at the back, the 2 satellites in the front working, yes or not, when the 2 satellites are going at the back, the 2 satellites are working in the front and able to give a better picture over the, and then this way, and again there is an, I said not only this way, there is a series of 6, there is a 4 4 4 4 4 4 4 4 24 satellites to cover. Here the 2 satellites, here the 2 satellites, again there is a one orbit is here. In this orbit there is an again 4 satellites at the back and are also. So there are some different kind of orbit has been made, and then 4 4, so that at a time there is a 6 groups, and one group has 4 satellite, or at a time they have made it to move like this. They can be taken what I said that going at the back also, because they are 12 hours, because they are what is I said the 12 hours, and they are able to go at the back, and they are covering at the back, they are covering at the front also, everywhere in the different parts of world, and they have a better signal. Again listen me carefully, better signal and better picture, okay. And if they have a better signal, better pictures, then they are utilizing this, but what is the problem with this? One satellite goes, then another satellite comes in that region, one satellite goes, another satellite, so little bit there is a problem in, I said that signal. This is the problem. They have the GPS system of USA, there is 24 satellites to cover the whole earth, and particular belt there is a need of 4 satellites, okay, and the whole earth has been covered with the 24 satellites, but what is they are getting the giving the good signals, giving the good pictures, position, navigation, time, but problem is there, when one satellite goes, then another satellite when it's come, there is some kind of time delay, and that causes some problem in it, okay. So GPS system of USA, GPS system of USA has, I said, that better signal to the world, better signal to the world, better pictures where they are, better picture position and all. But what is, I said that there is a little time delay due to the another satellite which is coming, time delay, yes or not, and sometimes lost signal. Suddenly आपको क्या क्या होता है आप देखते रहते हैं, when you are watching, I said that, जब आपने कभी देखा होगा कि yes Uber is coming but in between signal lost signal problem, yes or not. So there is a need more satellites to be there, and I said that there is a time delay, means one satellite goes, another satellite coming in that position, so there some seconds of delay and then signal lost. This thing is there. The GPS system is covering the whole world, but if I am talking about IRNSS of India, I said that okay, signal is not too much, it is, signal is always coming, not better signal, but it is signal is coming, picture is also there, but no, I said that lost signal problem. Lost signal problem. And another, that much I can say right now, because IRNS when I will discuss that time you will be better. So this is, I said, the lost signal problem is not there because of the, always our satellites are overhead. It is clear? Always it is overhead. So GPS system, they can't use their geostationary earth orbit like that, because it is not good for high latitude and polar latitude, but the GPS system, therefore they come into the which one, medium earth orbit. शायद आपको समझ में आ गया कि India is using geostationary earth orbit for their navigation because India is in a good position near to the equator. Therefore, our navigation system is maintained by Geo, but the country like Russia, like country like Europe, country like USA, country like China, they are far away from this equatorial region. So they can't use the Geo kind of it, okay, they cannot get the benefit of it. So therefore they come into the medium earth orbit where the better signal can be there, the better picture can be there, but there is some problem of lost signal. So therefore GPS, if I say that navigation के लिए USA GPS system को use कर रहा है, and there is 24 satellites, and Russia is GLONASS, Europe Galileo, and China BDS, and all are if I am talking about, all are in medium earth orbit, because their position is away from equator, means somewhere in the mid latitude and high latitude. Therefore Geo cannot work better, and these navigational satellites, they are away from equator, means they are in the mid latitude and little high latitude. So therefore उन्होंने बोला कि नहीं यार मैं मिड लैटिट्यूड में आके so many satellites I'll put to cover this. So they have to put lots of satellite to cover, Is it clear? Yes, that it will be there. And at the same time I have said in India case, India is using, so here it is, I said that they are using in the MEO, medium earth orbit satellite, here it is, because they are away from the equator and mid latitude, high latitude, Geo is not going to work for them. So what they therefore they have utilized MEO and the lots of satellites, okay. And then and India case there is which one, IRNSS, and always over India. If India map is over there and it is equator, so there will be always looking overhead India, and India is near to equator, near to equator, or near to equator in tropical and subtropical geo works fine. So therefore we can be able to say, in the one word we can say that most of the world developed country, they are like USA, Russia, Europe, China are in the mid latitude and the high latitude region, and they cannot geo. Therefore for their navigation, MEO is one of the option with several satellites. MEO is one of the option with several satellites. But India is near to the equator, therefore their navigation is better with the help of IRNSS geo. Better not need, they are 30, 31 like this, okay, 30, 31 like this. So we have been able to see MEO also. What is medium earth orbit? Medium earth orbit. So in the medium earth orbit, India does not allow. Our IRS, Indian remote sensing, is covering what I said that from the, I said that low earth orbit, and our all other functions, telecommunication, broadcasting and all are, it is covered by the geo itself, means geosynchronous earth orbit and geostationary. So I do not need MEO, I do not need MEO, okay. So this is the way that it is. I said we are, I said using our navigation for it is in the geo, but world navigation satellite is using MEO because it is away from the equator and not able to get the better signal from the geo, okay. So isliye they are missing and coming towards this one. So perhaps it is clear to you, perhaps it is clear to you. Yes, always satellite has to, what I said that this antenna here and there, so many things that has to do. Perhaps my point of concern, it is clear to you that it is medium earth orbit, mein there is no satellite of the world and India, but world has only one satellite that they are using. It is, I said that, navigational satellite. Yes. Now we have covered these things which is clear to you. So I have a great pain in, I'll cover it later. Beta, you know that अभी सब कुछ पूछ लेगो तो IRNS के दिन क्या पढ़ाऊंगा. If you'll ask me everything IRNSS, then what I will teach you when I'll do the IRNSS, huh? You know that there is a satellite system, space. I need different station and controller on the ground, and there should be a consumer. क्या आपके फोन में, tell me, in your phone Navic system, Navic app is there? Do you have Navic in your app? You will say no, sir. We have established from the 2013 to 2018, we have established 7 IRNSS. Our space ground is clear. Now we are preparing our some I said that stations, controller station. Thereafter we'll make a better app that every one of India can, what I said that, have a Navic, means every phone should have this, every phone should have in their system Navic instead of GPS. Instead of Navic, they instead of GPS, क्या हमारे फोन में है? If we are not, I said that, if we have not, I said that, listen me carefully बेटा, मैं भूल जाऊंगा. If we have not very much, अभी हमारे ना तो फोन ऐसे तैयार हैं, we should talk to the Samsung, we should talk to the every, I said that, phone company. Their system should have not GPS equipped software and something like this, and but they should be always equipped with Navic for India. So we have to prepare. Probably 2020 and 2021 IRNS Navic will start. Okay, Navic will start in this period. You know that therefore 3, I said that you can be able to see one goes in the dark, there are 3 satellites. I have at one position Geo here, one goes back, then this will come here, this will come here, always India will be under this, one Geo is not there, therefore we are putting more Geos to cover this one. Okay, someone is giving signal, और ये सिग्नल की बात है, लाइट का जो रिक्वायरमेंट आपको मैं बता दूं कि लाइट रिक्वायरमेंट इज ओनली व्हेन इट इज पिक्चर हैज टू बी टेकन. So perhaps all these things are clear to you. That's good. My and Realme, that if it is coming in your phone number, that is good. Abhi right now so many companies have, every company has to be prepared for this, then we can launch it. Okay, the 3 section has to be these 3 segment, space segment, ground segment, and we have to cover consumer segment, those who are using it, user segment. Then this will start, and it will be थोड़ा सा बैंड से भी लेकर लेटर ऑन आई डिस्कस. सो परहैप्स and I'll request you today, beta, I am going to request all of you two things I'll say you. One thing, please let me teach you till the end, and thereafter you ask your question in the, I said that 10-15 minutes my explanation. And sometimes what happens, same student, one student is asking this question, the another student is after some time asking the same question, and I am giving 2-3 explanation for the same question. So please, if one student has asked the question, that is okay, then you do not repeat these questions and ask the question what I have taught. Clear hai? And another thing I will tell you that this generally it becomes little late night taking these classes. From tomorrow onwards, 1 hour before, instead of 6 o'clock, your class will begin at 5 o'clock. Okay, and it will go till 7:30. 5 till 7:30. From tomorrow onwards, it will 5 till 7:30. Thanks to all of you, beta. Read the notes and again, let the topic to be get covered. So many things which will come to you, and your doubts, I think I am trying to give, you are understanding at least 70-80% and you are remembering. I think some of you are understanding 100%. And you know that 100% is a big achievement, and in some, but 70-80% if you are understanding, you are the best side. You are at the best side. Some things missing because of your own your conceptual understanding due to your background. So थोड़ा सा पढ़ोगे तो आपकी concept पूरी clear हो जाएगी. Read it again and again, and tomorrow it will start at 5 o'clock and it will go till 7:30, beta. And when I'll say that ask your question, then ask. Again I am requesting you that it is tomorrow what you do when I'll finish the class, thereafter I'll give you 10-15 minutes and enrich your with those doubts will be cleared by me. Perhaps you are understanding that Pankaj sir can clear your doubts, and I am trying to teach you better. Yes? So we'll meet tomorrow. And we'll further go, but remember from tomorrow onwards Do not ask question, do not ask question. Being a teacher, when I see something toward the I said that screen, I found that there are some questions are there. Listen me carefully, whatever the doubts are coming, write down. Probably whatever the problem you have, there are 2-3 students may have also. So at the end, I in one question I will handle the others question. So 10-15 minutes may everything will be, I said that clear. Okay. So tomorrow onwards it will be start at 5 o'clock. Video, if you are not in the class beta, if you are not in the class, backup video will be uploaded slowly and slowly. Beta, I said that the office timing, due to the some reason it has been come on to the 6 o'clock. It is becoming late night. It is becoming little night. I know that this is the corona period and administration does not allow to open the office for longer period. It is clear. So it should not open for long, little late, because everything that used to close here and there, and then you know that police wala also comes. So tomorrow it will start at 5 and 7:30. Okay. So thanks for your cooperation. Whatever you are cooperating me for tomorrow, I need more cooperation from your side. Okay. And I have little more headache today also. So I'll meet you tomorrow. Till then. सर मैं बहुत